Greetings, my name is Jani Savolainen and I'm founder and CDO of SQL Governor, the software company. Last time I showed you in my SQL Sessions how the blocking queries are identified with SQL Governor software from the SQL servers. So now this time I'm going to have in this sessions part 2 introduce you how to analyze extended events in the SQL Governor software. First of all, what are extended events? Actually, Microsoft has very good summary on this. It says that it's a lightweight monitoring system for SQL Server and related Azure SQL platforms, which basically means that if you think about the old SQL profiler trace functionality in SQL servers, the ones DBAs that have worked with the older versions of SQL servers know this. So it's a substitute and replacement for this profiler trace, SQL tracing. And as it says, it's a lightweight monitoring system. So it is actually querying a wide range of different kinds of elements inside the SQL server itself. So instead of using DMVs, you're able to use these extended events and just to select, cherry pick those events you want to listen to, and only those events and those columns, those fields that you want to select from the events, and then filter out only those perspectives of those events and their corresponding fields that you want to. And then you can select the target where to save this information. And you're good to go. And then it just collects that information that you have decided in your collector. So it's very lightweight compared to old school SQL profiler trace. And it's very versatile, flexible. You can do many kinds of event tracings there, and you don't need to write that much DMV code anymore. So it was introduced first in SQL Server 2008, then there was improvement to the 2012, and further improvement to the 2014 when it started to be, I would say, useful, very useful. So it's you are able to use straight SQL Server Management Studio, and in there you are able to see those, capture those events and browse those events and see what happens. But also you are able to build your own applications to listening to those events you want to capture, those events that you want to further on analyze. It needs a server permission to create any event session or alter any event session. And then this is from 2022, if I remember correctly, from there, yeah. And then SSMS view server performance state. It means like if you want to review those events that you captured in SSMS, you need to have the view server performance state. Right. Then the events captured by the SQL Governor are the SQL Server.rpc completed and SQL Server.batch completed, which basically means that any SQL store procedure or any batch given any ad hoc query by ORM, so forth, you get all of those, and those events are captured in the SQL Governor database. Then about technical benefits of the extended events. One of those, and not the least one, is the decreased performance overhead compared to old school query tracing. So imagine if you have a situation where you have a very high workload on your SQL Server instance because of the problematical queries. It may be blocking, it may be because of indexing, it may be deadlocks, whatever. And then you want to see what is happening there because you don't know, you don't have a view for there. So then you are able to just capture those events and filter them out and see very lightweight that what is happening right now, instead of trying to launch quite resource intensive SQL query trace. So then, of course, the rapid implementation for versatile needs is one of the big technical benefits. So when the legendary hits the fan, if I would say so, you're able to immediately react as a firefighter for those needs, just like triggering those events and see what it sends to the ether and then analyze that further on. Decreased need for DMV queries, as I earlier said, is very important because, as we all know, some of the DMV queries are very complex ones. Documentation has improved from the years ago quite a lot, so that is a good thing. But still, even though the DMVs are very, very well documented a long time, still some of them are very heavy use. So if you have busy servers, those DMVs, straight usage of those DMVs on top of all, it would be too much to handle. So that's why it's good to have in some certain collectors to especially these extended events. Then you are able to build your own logic on top of that and use just like it as an API and select whatever you want to from there, and then further on capture and analyze those workloads in some external environment. Not in log file, it can be also on database and so forth. As in SQL Governor, it's stored in the SQL Governor database. So what can extended events offer for your business then? So one is, of course, the better visibility for performance bottlenecks. You are able to see the various sides of the performance, if there are blocking statements, if there are deadlocks, if there is any kind of like, let's say, storage bottlenecks, indexing bottlenecks, like missing unused fragmented indexes. You are going to see so much telemetry data from the extended events that you are able to pinpoint most likely that, okay, it seems like this and this is the problem. Of course, you would need then much more information than just like a query performance, like calendar time, long-running queries, CPU time, reads and writes, and so forth. You would need to see also much more, but that's of course why we have SQL Governor software. You're able to see different perspectives of the environment. And then reduced downtime is one of the things also that you would be able to achieve. This means that earlier on, when the SQL Server was very busy, you wouldn't like to do there at these cases heavyweight query tracing. But now, because you're able to do the lightweight query extended events capture, you're able to improve your uptime in the long term. Optimized costs, of course, because, for example, if you are able to pinpoint that this particular query is taking 30% of our CPU, and if my superior asks that, okay, should we order more RAM or CPU or more storage or something like that, I say, no, just fix this one particular query and you have 30% less CPU usage after that and you're good to go. That's just like one practical example. Improved firefighting response. You're immediately able to see what is happening there when you launch lightweight extended events capture. You can see what is happening in your system and so forth. And then, of course, the application quality check is one thing. If there is problems with different aspects of the like schema or the ORM or RM or something related to let's say the quality of queries and so forth. So, and the structure of the database. So you're able to see that as well. Then the capacity planning, you're able to see the seasonality, the peaks, the p-values of the like P50, P90, P95, P99 and so forth of your information of the telemetry data if you just further on analyze that data in such form. Of course, it's not ready there, this kind of statistical information of those like queries, for example, but if you have a software like a SQL Governor that is built in our software, the further analysis of those footprints of those workloads. And then the security audit support, last but not least. For example, if you have failed logins, authorization problems, or something suspicious in the security side, so you're able to also inspect those events ongoing. Okay, so next, then the demonstration of the SQL Governor by capturing queries with extended events. So what I'm going to do, first I'm going to identify the CPU pressure from the SQL Server performance counters. Then I'm going to trigger a live extended event session, investigate extended events history. So extended events, X events, XE, all the same. And then I'm going to hunt down the CPU hogs from the extended events feeds and narrowing down the potential root cause by checking various aspects of the workloads, like the weights, the performance counters, how the queries are evolving over time. So you will see that I'm actually able to quite well, based on this information, to make this more narrow, narrowing down the potential root cause. Okay, so let's go to demonstration then. All right, so here I am with the demonstration now. And first of all, let's go. Now we are on a dashboard. So we are able to see the overall state of the SQL servers in our estate. And let's say that there is a situation that there has been reporting of slowness on a certain SQL server. That is all we know. We know that the DB Governor database has been slow, and we want to inspect what is wrong in there. So we know that this is on SQL Governor domain, and let's go to monitoring first. Analysis, and we know, let's say that instead of last 24 hours, it's been on SQL Governor domain, it's been on dev go on-prem server, and we want to look at the last 7 days because it occurred yesterday, and now the display time is UTC time, so the problems occurred in that environment 7 o'clock. So now we narrow down and find out where is the 28th day, because today is 29th of May. So here we have it, and we can see really that there is long waits on the at 7. So that's peaking there. And now we know that this resides on the SQL Governor instance called MS SQL Server, and we know and notice that there is the same peaks ongoing there. And now we click on the DB Governor database because we know that this is the database that is running that application where we had the problems with. So now when I'm on this DB Governor database, I'm able to see that actually when I select that spike there on the weights, I can see that it seems like there is really 7 a.m. is a peak. There is most of it is CPU weights, some of it is IO weights, and then MISC weights. Interesting. What if I click on the different weight types? So I want to see just the CPU weights. CPU source scheduler year and CX packet. Maybe a parallelization problem, maybe bad query. It can be many things at this point of time. It can be on indexing, statistics, whatever. But let's look if there is something else. IO. Okay. Now it tells us that it has a page IO latch X and page IO latch SH, especially quite high there. So and that's deviating from all the other norm what it had earlier on. So it's most likely related to those weights, which narrows down the problems that we are most likely facing here, because now this is a good point that this may be the slowness of the some queries, the root cause there, we can assume that it cannot be most likely like a search argument problem, because it's only in this particular case. So it's most likely a single query or some queries running on that time. And then it cannot be like an implicit conversion problem, like Unicode to varchar or something like that. It would be always slow. It can be some procedures that are running only that time and causing some problems. Then it would be like a statistics indexing problem most likely. Also, it would be, this is important part of kind of like a discussing by myself, that what would it be, because it narrows down the problems when I go further on in this analysis. Then it wouldn't have been most likely also not like any kind of like well, it could be like a parameter sniffing problem. That would be because it would be like a baseline is normal, but then if the certain statistics are being hit in statistics skewness or something like that, or a lot of range rows there to return, so it would be much more slower than normally. That could be one case, and so forth. So what I'm going to do, I'm going to inspect it further on. I go to performance counters, and by the way, in workload analysis I would be also able to see the planned cache, and I can see there is something deviating, but now I want to show you the telemetry collectors, so that's why extended events collector captures, so I'm not going there. So then we have here a performance counters, and on performance counters side we are now on this database, but let's go to server level and let's inspect that same point of time, UTC. So 28, and there it is, 7 o'clock. Disk I/O operation have spiked. Disk I/O latency has been just before that quite high, which is interesting. CPU usage has spiked from around the baseline of 2 to 4% up to 13%, so 10% units more CPU. So it means like it's CPU intensive process what is happening there, and it seems to it also seems to have let's see actually what it shows in SQL Server instance level. So instance level, and we want to narrow it down to the same particular time range, of course. So here we can see that disk I/O operation have spiked, reads and writes, and then also CPU usage after CPU usage at the same time. So and page splits, which is interesting. It may be based on this information what I see, that it may be more into statistics, the indexing problem, or also it may indicate some memory specific problems here. But now to be more kind of like convinced what is wrong here, we go to extended events telemetry. I would be able to just go to management here, and then I create session. I give it a name, my telemetry session. Oops, too many S. So now I'm just launching this for the SQL Governor server, on-prem instance, MS SQL server, server and MS SQL instance. Select specific databases, DB Governor, and then I'm able to launch this session. Now it's waiting there and soon to be running and gather some events. But now, because it's constrained time and I want to see if I have gathered telemetry earlier on, and as we can see, I'm a lucky guy, because here we can see that the telemetry collector has been running there earlier on already, and that particular collector has been running actually during that time when the unfortunate event occurred. So I can go to workload history and select this telemetry collector. I can see it has been running on that day, and then when I have these events here, I'm able to see that the update planned cache is the most consuming query in terms of CPU, and other candidates are like USB deload statement, finalized batch, some procedure, transaction. Those all together are the mostly dominating in terms of CPU. And also what I can see is that the update plan cache, even though it takes that much CPU, it doesn't execute that often. So that is a good candidate of this problem, because the root cause, or one of the root causes of this problem, most likely more than one queries are the problems because they indicate so high CPU, and also because this load D statement would explain the high reads and writes in the database, as well as actually the update plan cache. Sometimes these reads would be expensive also in a way how it's implemented, but most likely this is the root cause of the disk operations. So it's not so clear that there is one particular query that is dominating and doing all the bad things. But we wanted to decrease CPU, so first I'm going to see this update plan cache. I click on this, and now I can see in UTC time these events here, and this is the same event, and I can see immediately that typically it does not take many seconds here, almost next to nothing, and when I go to CPU, I can see that CPU and logical reads increase in some of the cases. So the plan may be changing there, or there might be problems with something else. Let's click on CPU to be more convinced. Okay, it shows that it's zigzagging, either using a lot of CPU and reading a lot from the database, or then it's using not at all, and still and it's not writing. That is also important notice. So I would say that the most likely this problem is statistics and indexing related, because that would explain that every now and then it works fast, every now and not, and also a plan/statistics problem, query plan/statistics problem is the most highly likelihood of this root cause. And logical reads, as you can see, they correlate with CPU. So this is also important notice that says it kind of like makes that earlier assumption most likely correct. Then there is writes also, but those writes not much, 1000, bit more, like 400 and so forth. Reads and writes do not correlate that much, but at some level yes. But CPU and logical reads, they correlate very well. Okay, so we also can see that normally this query, typically on baseline, it just lasts for 6.5 seconds, 50% of those queries, and then 95% of this query is like deviating up to 40 seconds. So it's quite a difference there in the next 45% on top of that 50% of queries over time. And also the reads and reads are elevated here, so which makes it questionable if there is something changed in the indexing. Okay, so now this was interesting, but also if we go to fingerprints here, and we want to see that here we can see, let's take now the correct time zone. So now it's 7 a.m. here, and the SQL Governor engine has produced quite a lot of, this application has produced half of the CPU workload. So this is the main reason. Also proxy API is like 30%, and then Governor itself, the UI has produced like 15% of workload. So I want to see, this explains 50% of the 13%, as we remember 13% CPU utilization. And we are developers, we want the CPU be as low as possible, even though normally 80% starts to be problematical CPU in the production environments, but not like 10%. But we want to optimize everything, so we want to go here, and we see the top 10 queries by CPU, and we can see once again update plan cache. Then there is another one, USB load D statement, and it's also very remarkable. If you think about these two ones, they all together they are about 75 seconds of all the waits on this application. And if we calculate all of these together, so it's like 75 and then plus 25, 110, 13, something like that. 113 seconds, so 75 out of 113 is pretty much same as 65% of 100%. This means 2/3 of workload of the 50% of the CPU. So it's like, let's say about 3-4% of the whole CPU spike is just because of these two queries. So if I take a deload statement, for example, here, and see what is happening there, I can see that there is just one enormous query that has a lot of logical reads, and CPU time is like a lot. So now I know that actually, yeah, this is the one I should go to optimize with. So those two queries, and because it has so many logical reads and writes, how about that? Quite a lot. So I would like to go, next step would be to investigate what this stored procedure is actually doing. What are the statements, what are the plans, what are the indexings and things like that. But that is another story. So this is how it's easy to narrow down the potential root causes, and in the becoming sessions I'm going to show you how easy it's to find out what is wrong, for example, in the query indexes, so you're able to narrow down and find the root cause of the problems. But this is how to narrow down with weight statistics, performance counters and extended events. First, like what is the problematical resource, then what is like problematical weights, what are the problematical queries, and then would narrow down to go and inspect those exact queries and what is happening in there. So yeah, this was about the monitoring and extended events capture at this time, and I hope you liked it, and I really looking forward that you are going to follow us later on as well. So over and out. Thank you very much.